Switching gears a little bit, we're talking about systems of now inequalities, which all a system is just a really fancy name for a case of math that has more than one equation, and in this case more than one inequality. We are going to do some work with systems of inequalities, but for today, or for right now in this moment where we are, we're just going to graph them. So let me show you kind of, let me start with one example, and then I'm just going to lay out a couple other details. So I am going to sketch out some very exciting looking graph paper here. And let's see. Okay, so far so good. Very, like I said, very, very fancy. I'm gonna look at two inequalities. I'm gonna say y is less than or equal to x squared minus 1. And then I'm gonna say y is greater than negative 3/4 x plus 5. Okay, no idea why I picked those numbers. They felt right in the moment. So here we go. This first graph. First of all, the graph of x squared minus 1. So that means that if x is 0, y is negative 1. If x is 1, y is 0. Same with negative 1. Remember, parabolas have beautiful, beautiful symmetry to them. If x is 2, 2 squared is 4, minus 1 is 3. So 2, 3. Get that good symmetry. If x is 3, 3 squared is 9, 9 minus 1 is 8, which takes me to 4, 6, 8 to the top of my graph. Exciting how well that worked out. And there's my parabola. Kind of. Parabola, obviously you need to connect those. This is less than or equal to, which means I'm going to draw just a smooth line, no dashing, no dancing, no prancing, no vixen, no, just kidding, but basically smooth line. That's y equals x squared minus 1. Y is less than, which means I want all the points that are where y is less than that graph. And so that means I'm going to do some shading, because I need to account for every possible ordered pair. So I am going to show that by shading below. Okay, next graph. Y is greater than negative 3/4 x plus 5. Okay, that's just a line. It's got a y-intercept of 5, 2, 4, 5, and a slope of negative 3/4. So down 3, run to the right 4. Down 1, 2, 3, run 2, 3, 4. Now, this is a dashed line. A dashed line, and it just so happens that we have greater than, so we are going to shade above. Okay, now thanks to that lovely, lovely shading, hopefully you can see a little bit of where the overlap is, because when we are talking about what is the solution, and actually I should probably say what are the solutions, because it's any ordered pair in the overlap. So an example solution might be the ordered pair 1, 2, 3, 4, 5, 2, 4, 5. I've got blue and green in both spots. 5, 5. That might be an example solution. Now I could list infinitely more, as long as they're in the blue-green overlap. That's the biggest thing, is we have to make sure we're checking out the overlap. As you're doing these questions, reminder, less than or greater than gets a dashed. Less than or equal to, greater than or equal to gets a solid. If you have an equation that looks like this, y equals a number and there's no x, that is a horizontal line. It will look something like this. If you get x equals, and there's no y, that is vertical. And then obviously, whoa, my bad. Look at that. Yay, math. So just something to be mindful of, aware of, whatever. But we're just going to be graphing these, pretty basic, nothing too terribly exciting. Good review of how to graph. Obviously, we love using Desmos for graphing. That's a great way to check. We will apply this to some different problems, but for today, graph, check out the solutions. All is good.